Hey guys, a quick confirmation. I hope you can hear me. If yes, please confirm by typing as yes in the chat window, please. Okay, I can see the learners joining in. So folks, do you have any questions or any queries from the last session? So please let me know. And also let me know, like, how did you like the yesterday session? Like, were you able to follow, or is there is anything that you want me to change during the pace of teaching? So please let me know that as well, so that I want to ensure so that I can adjust the session and ensure that you're able to follow along with me. Okay, Rakesh says all good, sir. I was able to follow. Okay, thank you, Rakesh. Okay, Rajiv says, sir, no question, sir. It was very good. I was able to follow. It was the first time that I saw. Okay. Thank you, Rajiv. I'm glad that you liked it. Okay. And Satyam also says all good for me. Thank you, Satyam. Okay. Sanjeev says all good, sir. It was an interactive one and I loved it. Okay. Thank you. Sam- Samyukta says, sir, it was very insightful and it was very good. Okay. Thank you, Samyukta. Raghvendra says, sir, I'm yet to practice the hands-on, but all good. Okay. Thank you, Raghvendra. Okay. What about others? Like anything you want me to change or were you able to follow? Okay. Prabhakar says, sir, it was good. Perfect pace. Okay. Thank you, Prabhakar. Okay. Thank you, Sridhar. Definitely, Sridhar. Yeah. Like Sridhar says, can you show some example with machine learning? Definitely, Sridhar. That's the agenda of today's session. We'll be taking an example of machine learning. We'll package it and we'll make use of GitHub action and implement the CI/CD. So we'll do that today. Okay, Lakshmi says, sir, I'm not aware of Kubernetes. Okay, that's fine, Lakshmi. So as I mentioned, we'll be looking at it at a very high level. I'll show you the high level steps. And there were other webinars that I've conducted on Kubernetes. I'll share the links as well at the end of today's session. You can refer those session. to get some details around Kubernetes too. So, as part of today's session, I'll be explaining what happens at a very high level. Yes, for deeper understanding of Kubernetes, you can refer to those additional videos that I'll be sharing. Okay, no problem, Lakshmi. Okay, thanks a lot, guys, for joining in. So let's get started with the day two. So, folks, I just want to ask you one important thing. So, were you able to practice the hands-on that we discussed in the last session? So, I can see most of the learners have joined. So, I can see more than 200 participants. Okay, so were you able to practice the hands-on that we performed in the last session? So, I see multiple responses: Lakshmi, Ajay, Akshay, Sridhar. Pratyusha, okay, Pratiksha, all of you are saying as yes. That's great. Okay, what about others? I see only few responses out of all the participants that I can see here. Okay, some folks are were not there in the last session, but they went through the recording very lately. Okay, that's completely fine. Okay, Satyam says I was unable to join. Can you share the recording? Sure, definitely. So, folks who have joined today and who missed the last session, so I'm sharing the link here in the chat window. Okay, so let me do that. So bit.ly/manifold AI learning. You can just refer to this link team for the folks who have missed the last session. I'm just pasting on all the channels too, just to ensure that uh, you get it. Okay, so I've shared you the link, guys. So what you can do is just open that link. Okay, once you open that link, you'll be redirected to a page of webinar learning material. Click on Access Now for free, and under the day one, Git and GitHub. So this is where you have the MLOps workshop. So you have the video, the session's recording, which was conducted in the last session, the code that I have typed in the last session, and along with that, the slides as well, the slides that I've used in the webinar. Okay, you can get the access over here from the portal. Okay, so please check in the chat window. Can you check in the chat window once, Satyam? Or maybe I'll share it to you separately as well. Okay, clear, folks? Any other questions? So can we start today's session? Please confirm by typing as all good so that we can get started with today's agenda. Okay, Akshay, Diksha, Samyukta, Sridhar, Praveen, Prakash, Diksha, okay, Kavya, Ramesh, Lata, perfect guys. Okay, Satyam, okay, great. Okay, thank you so much guys for your confirmation. So let's get started with today's agenda. See, what we did in the last session was, in the last session, so we actually went through the basics. So we have understood what is MLOps, why do we require the MLOps, and we have looked into the concepts of the version control system, and we have understood about what exactly is this version control system and the concepts around the Git, and we have set up our account, that is Git account. uh, that is we have set up our local system with Git so that we can track the version. We looked into the basic commands of working with local repository, and then what we did was we also looked into the concept of branching, how to create the branch, how to perform the changes, and so on. And then we have hosted our local repository on the GitHub, which is a remote repository. And we have seen the basic commands of pulling and pushing. So that's the important commands that we have seen till now in the learning journey. Now, as we progress in today's session, so what we'll be doing is we'll be performing the entire CI/CD thing in a hands-on manner. And this is little advanced where we'll be utilizing various tools and technologies. You might not know on the day one about all those technologies. I'll do my best to simplify it so that you understand it, how it is working together. Okay, so we'll be seeing as how to create a GitHub Actions file, and we'll create a Docker container on a machine learning project. We'll create a Kubernetes configuration file. We'll deploy the machine learning application that we have created on the Google Kubernetes engine. And we will be implementing and testing this CI/CD pipeline in a hands-on manner, where we will do some modification on our source code. We will commit those changes into our repository, and we would go ahead and validate it whether it is deployed, the latest version has been deployed into my server or not. Okay, that's the kind of validation that we are going to perform right now. It's a basic CI/CD pipeline which will be implementing it for the machine learning project. So let's go ahead and perform this activity, guys. Now, for the benefit of time, so what I have done is I've made use of the already created machine learning project. So if you have been following my work, so we have published a course on manifoldai which was about the machine learning deployment. So there is a YouTube playlist around this as well. So here, under this course, we have actually created the deployment using the Flask application. So there's an end-to-end deployment v1 file that I have attached over here in this section. So I'll be using the same code file which we have implemented last time, and we'll be deploying that application into the Google Kubernetes, and we'll create the GitHub action and perform the automation, guys. Okay, I'll be making use of this file. So if I bring up that file, so you'll be able to understand what is happening right here. So here, let's take a look into the notebook that is created. So this is basically classification.ipynb file. So this is a notebook which has the experimentation part and creation of the model part. So to give you an idea, so to get started here, I'm loading my data set. Okay, I'm loading my data set, and once I load this data set, which is an iris data set, a very simple example that I'm using right now. If you look into the shape, there is 150 rows and 4 column, a simple iris data. So we've got 4 features, right? So those 4 features are represented in my data, and this is basically a multi-class classification. I've got 3 classes, right? 0, 1, 2. So it's a multi-class classification. Okay, now the target names are setosa, versicolor, and virginica. So basically, given the sepal width, petal width, given these features, I want to classify each row to one of the classes, that is whether it is setosa or versicolor, virginica. So I want to perform this basic classification. Now I've got a question for you. So when I say classification, so to what kind of machine learning does it come under? So what do you think, guys? So under what type we say this classification is under? Okay, that's correct, Akshay, Deepak, Sridhar, Lakshmi. Okay. So what about others? What do you think? What kind of task that I'm performing right now? Like what type of machine learning it is? Sridhar, Samiksha. Okay, I see some more responses too here. Uh, Dheeraj, perfect, guys. Yes, as most of you have mentioned, it is a supervised learning, which is nothing but the classification task. So the type of machine learning that I'm implementing is the supervised machine learning. So I hope we are all good right now with what we are doing. So it's a supervised machine learning, and it's a basic classification. So since it's a classification, I have to use the model which is suited for this classification task. So for the demonstration purpose, here I'm taking a very simple approach, which is nothing but my decision tree model. So using this decision tree model, we would go ahead and find the patterns in the data set. So I'm importing this decision tree classifier. Then I'm also importing the standard scaler, the train test split function. So this would help me to split the data, and standard scaler will help me to apply the normalization on the given data set. Okay, next here I'm splitting my data set into two parts. One is training set and the test set. So I'm just splitting in the ratio of 80-20, which is a common activity that we do whenever we are applying any machine learning. Now, once I split the data, I'm going to apply the standard scaler on my training data set. Now, remember closely, when I'm applying the standard scaler on my training data set, it is fit transform on the training data set. So to give you the idea as what happens when I apply this transformation. So basically, we will be going ahead and finding the value of mean and standard deviation for each and every column in my data set. And once I get the mean and standard deviation on my each and every column in my data set, I would trans I would go ahead and change the values of each and every row such that I'll deduct the mean of that column and I'll divide it by the standard deviation. Now by doing like this, I'll be transforming the data. Okay, I'll be going ahead and transforming the data. Now I've got a question for you guys. When I apply such standard scalar on this given data set, what do you think is the range of values that I would get if I transform my column, each column? So what would be the new range of values that I would get? Okay, let's talk about one thing. Okay, let's talk about mean. What would be the mean value if I perform such transformation, and what would be the standard deviation value on that entire column after I perform this transformation? So I know that most of you are responding. Okay, Lakshmi's, Samjeev. Okay, uh, so uh, okay, so Satyam. Perfect, guys. So as most of you have responded, yes, the mean will be 0 and standard deviation is equal to 1. So that's how the standard scalar will have the effect on my given data set when I apply it on the given data. Okay, so I hope it's clear now. So we are going to apply the standard scalar, and we are able to transform this data such that we'll have the mean as 0 and standard deviation as 1. So I'm applying this on my training data, and using the mean and standard deviation of my training data, I'm performing the transformation on the test data. Okay, so that is happening here in the step, and then on this transform data, we would go ahead and apply the fit. Okay, we can go ahead and apply the fit. It looks like, let me do one thing, guys. Okay, so I think in this code, maybe I'm directly applying my training data. Okay, so you can just go ahead and run it this way as well, where you would perform the transformation. And after you perform the transformation, you can go ahead and transform the data. Okay, I'm not going to modify it, so you can take it as an hands-on. So in this case, I think I'm just for the demonstration, I'm directly performing the fit over here in this code. Okay, once that is done, so once that training has been performed, okay, so what we are doing right now is, okay, we are going to perform the fit on this data set, and after that, the important thing is we are going ahead and taking the dump. Okay, we are going ahead and taking the dump of the files that I have got. The two important files are final model.joblib file and standard scalar.joblib file. So they are nothing but I'm externalizing these files. So let me do one thing since it's used. Let me just re-execute this code that I have got. I'll just launch the Anaconda Navigator and I'll execute this code so that I can show you right away as how it works. So what I'll do is, it's a good activity as well. So here, yeah. So what I'll do is, I'll just quickly fix this. So instead of performing the train with xtrain and xtest, we'll make use of it in this way. Okay. So I'll just say run all so that the everything will be executed. So what I have done is, after executing everything, if I bring up my folder structure, so we can see that the two new files have been created. One is a standard scaler and the other one is the final model. Okay, so I have actually saved these two files with me. So these two files I have actually exported. The reason because here, whatever the model that I have created just now, it is basically present in my notebook. If I want to use it outside this notebook, I have to save it somewhere so that I can share it as a file. And for that specific reason, I went ahead and saved that file. In order to save that model as a file, I've made use of a library that's called as joblib library. And using this joblib library, I have saved it and I've made use of the function of dump. And using this function of dump, I'm able to go ahead and save it as a file, that is final underscore model dot joblib. Okay, I'm able to save it as a file. So I'm saving my model as well as I'm saving my the standard scaler which I've saved earlier. Okay, so that's the main intuition of saving these two files. Now, if I'm building any machine learning application, at that time I can go ahead and use these file itself. I can use this file and load the model. So I can use this file and load the model and I can apply the prediction on top of it. So that's how the approach is being followed. Okay, so to go ahead and perform this activity, so what we have created already is we have created a Flask application. If I bring up the code for my Flask application, here there's a file that's called as app.py. This is basically my Flask application file. So Flask is a library that we use it to create a front end using Python programming language. Now in this case, so like I have already implemented this Flask and this Flask based application. And if you just look into the code right here, I'm importing the Flask library, NumPy library, Pandas library. I'm also importing the joblib library. And along with that, here I'm going to load that model that I have saved earlier from this file structure. So I'm saying it as joblib.load. I'm loading the model from this file, and then I'm also loading my standard scaler. Okay, I'm also loading the standard scaler. Now, when someone launches the Flask application, by default, I'm routing it to the index that is slash. Now, at this place, I have created an HTML file. This will be rendered for me when someone goes ahead and launches my Flask application. So the code of this index.html is present inside the folder of templates, and under this there is an index.html where there's a file that is present and it's a HTML file, and I can just show you to you as well. So this is basically an HTML file which is index.html, and using this front end which is my web, which is the index.html, this will be opened when someone launches this Flask application. Okay, so that's what this index.html says, because I'm making use of the function that is called as render template. So using this render template function, so we would be going ahead and opening this index.html. Okay, so that's what is going to happen. Now, if someone goes ahead and launches the slash predict, so these are nothing but the like the path guys. Okay, so when we say slash, it is basically the home page. So if you go to the flipkart.com, when you say flipkart.com, it is indirectly saying that this is the home page flipkart.com slash. It is nothing but it's a index page. Okay, now if you want to go inside any specific page, what you will do is you'll say flipkart.com slash, and you will mention the page name, right? Let's say clothing. So that's what I'm saying. If someone goes to the slash predict, and the method that I'm using is post. So when we are working, so we generally have multiple methods that are supported, like one is get and the other one is post and so on. So in this case, so I'm implementing the post, okay, which means I can send in the request as a post request. I can send in the post request and I can get the response. So I'm using the method as post, and after I get this method as post, okay, so what I'm going to do is whatever the input that I'm getting in my front end, I'm just processing that input, performing the transformation, and generating the prediction. And if the prediction is 0, I'm mentioning it as setosa. If the prediction is 1, I'm mentioning it as versicular. If the prediction is else, I'm mentioning it as virginica. And this is going to render the predict.html. And if someone tries to run this Python script, so he or she is going to get the front end right away. He doesn't have to mention anything, he or she. So everything is mentioned over here. This underscore underscore name underscore underscore. So this is a special value that we would mention, which will ensure that what exactly it has to run when someone is trying to execute. Okay, this is a very high level idea about how this application would look like. Now for the demonstration purpose, what I'll do is I'll just run this Python Flask application. So I'll just say Python, uh, the file name that I've got is app.py. So if I press the enter key, so it says, okay, it is running on my server, and this is the uh, host of 5000. Under the host of 5000, it says my application is running. I can go over here and I can go to the local host of 5000. See, it says ML model deployment demo v1. So my application has been deployed in my local system and I'm able to view it. And there is an instruction over here. What it says is we have to enter the inputs for the machine learning model, which is separated by spaces. That is how I have designed this application. So the reason that uh, that I have mentioned, because that's how I have implemented in the backend, guys. Okay, so for the demonstration purpose, I'll mention four values like 5, let's say 23, some 4 and 1. Okay, so they are just random four values that I'm mentioning. Now what happens is if the user mentions four values, so each value is being mapped to my individual feature in my backend. Okay, it is being mapped to the individual feature in the backend, and when you click on the submit button, so it is going to process my individual input with the help of standard scaler, and it is generating the response page. Okay, it is generating the response page. So here it says my class is versicular. So my model has been deployed in my local system. Okay, this model has been deployed on the local system. So that's a good thing. So we have been able to perform the deployment. Now, the next thing that I want to do is, okay, so I want to go ahead and ensure that this model that I have created, it can be run on any system when someone is trying to execute. Now, the question is, how do I do that? How can I ensure that this model that I have created will run on any system? Well, I can only ensure that my model which I've built right now can be run on any system by ensuring that the dependencies are maintained, which means whatever the version that I have used in my local system, I have to ensure that the same version is present on the other system as well. Now, this brings to the topic that we have discussed in the earlier parts of our MLOps journey. So if you remember on our previous live sessions that we have conducted, so I talked about packaging the machine learning model. So we've talked about the packaging the machine learning model where we have understood about how the importance of packaging and the requirements of the same. So because of that reason, so obviously to ensure the repeatability of the model, we'll have to create and maintain the consistencies as well. We'll have to create the requirements file, which will capture the same elements that I've got in my local system. See, the important thing that I've used in order to build my Flask application is one is Flask library and the other one is scikit-learn. And apart from that, I think I think there has been a usage of pandas and the NumPy library. So if I want to replicate this code in any server, that server should also have the same versions of the uh, libraries that I'm working with, because if there is any mismatch in the library, then we are unable to have it replicated. So for that reason, I'll just start by getting the version of the various application that I've got. So one is Flask. So it is 2.2.2. So what I'll do is I'll maintain a text file that is requirements.txt file, and over there I would go ahead and mention those version. Flask is 2.2.2. That's the Flask that I've used. And then let's check the scikit-learn. So it is 1.2.2. Okay, so that's the version that I have to maintain. Yes, it looks like I'm using the same. Next, NumPy. One dot two 4.3. Joblib. So 1.2.0. So I would just note down all the version, and I'll ensure that same versions will be captured in my requirements.txt file. Okay, I've captured all these files over here. Okay, I've captured all these versions over here. Okay, now once I've captured all these versions, what would be the next step? Well, once I've captured these versions, the next step that I'm going to do is I'm going to create a Docker file where I would mention the steps that has to be performed in a sequence so that this model can be deployed. So there's a Docker file that's already created. So if you look into it, it's a very simple Docker file that has been created, which captures the basic details and replicates the steps that we are going to perform. So first thing is I'm going to get a base image. The base image is Python 3.10. That's the base image that I would consider. And I'm going to copy all the files in my current directory. That is all the files that you see right here. I'm going to copy all these files. Okay. I'll copy all these files and I'll go ahead and copy it to my container. And I'm going to run the command of pip install requirements.txt. That means I'm going to install all these libraries in that virtual environment. Now, once I've done the preparation, then I'm mentioning what is my entry point. My entry point is Python, and the command that I want to run is app.py. I'm exposing the port of 5000 because that's the port in which my application will be running. So I've created this Docker file. Now, once I've created this Docker file, I can go ahead and run the command. I'll just go ahead and mention this commands to over here. So I'll just say first thing that I'm going to do is I would go ahead and perform the activity of build. So I'll say docker build -t, and I'll have to mention my uh, let's say a repository name. So just for the demonstration purpose, I'll use my repository which I have in my Docker hub. So I'll say docker build -t, and I'll mention as flask demo latest. Okay, and apart from specifying the Docker repository and the version, I'll have to mention as where my Docker file is present. I'll mention as dot. Dot means that's the directory. In my current directory, I have this Docker file present. So I'll mention this command in my command line interface. I'll just exit what I was running earlier. Okay. Now here I'm inside the folder where this Docker file is present. So I'll just run this command. So this will perform the Docker build. Okay, so this has performed the Docker build. Now, once the build has been performed, so let's go ahead and test if it is working or not. So in order to test, I'll say docker run -p. So I'll be exposing my port of 5000 to 5000, and the image that I'm going to run is the image that I have built. Okay, it looks like there is an issue. It says from work so cannot import URL code. I think this seems to be one of the issue with the Flask that we are working. So let me just go ahead and resolve it. Okay, so what the solution is, I think I'll have to add this as well in my requirements.txt file. Okay, let me again perform the build and we'll run the same. So to confirm, what I'm doing right now is I'm just trying to replicate it in a new virtual environment, which is a Docker environment where I'm using the Python as a base image. And in that image, I'm trying to execute all the command and see if it is working. Now I'm launching the container from that image to see if it would work or not. In my case, once I've fixed that code, it is working. Now, if I go to the local host of 5000, I should be able to launch it again. See, I'm now able to launch it, and this time I'm able to launch my application from the Docker container that I have created. Okay, so that is what I have done till now. So to give you a quick recap, so what I've done is I've created a Docker file using the Python Flask application, and then I have built that Docker container image. And after that, I went ahead and ran that in my local system to see if it is working or not. I'll take a pause here, guys. So any question, team? Do you guys have any questions or any queries? So please let me know. Do you guys have any questions or any queries? Okay, I see a question. Okay, it's not a question, it's basically kind of a query, sir. I've joined from YouTube. Okay. But there's a lag. Okay, let me do one thing, guys. So, folks, in case if you're having any lag, so what I'll do is I'll just mention the link, meeting link. In case if you're having a lag, whether it is through the other platforms, you can just use this link and join it into the meetings, and you can also ask questions as well once you have joined at a later point. Okay, any other questions, team? Any questions? Were you able to follow? Okay, so there's a question from Satyam. Satyam saying that why are we saving the standard scalar object? That's a good question, Satyam. So the reason that I want to save the standard scalar object because if I don't save it, think of it in this way. Let's say my values are 10 and 20 and 30 and 40. So during my training data, let's say this is my training data. Now on this training data, I have applied the standard scalar, and let's say once I've applied the standard scalar, the feature values will become 0 0.1, 0 0.2, 0 0.3, and 0 0.4. I'm just giving a hypothetical example. Okay, this is my transform data. Now when I'm performing the fit, I'm using this X as my X train, which is in the scale. Now, while performing the prediction, when my model is deployed, I'm getting the new data. Now, let's say when I'm getting the new data values as 30, 40, 50, and 60, if I directly use this value as it is to generate the prediction, it would be wrong because during the process of training, I have made use of my standard scalar to transform the data, and on that transformation, I have performed the training. In the same way, I have to perform the standard scalar first, And I cannot randomly choose any standard scalar. I have to choose a standard scalar which I have prepared during my training, and then I have to perform the prediction. And because of that reason, I have saved this standard scalar object as well in a separate file, and have used this file during the prediction. Okay, is it clear, Satyam? Okay, what about others? Any other questions, team? Okay, thank you, Satyam. Okay, perfect, guys. Okay, any other questions, team? Great. Thank you so much, everyone, for your confirmation. So, with your confirmation, I think that I've got, so you're able to get a high level details. I can understand if you're new to the Docker, don't worry about it, just look into the high level flow. Obviously, as you progress, like as you progress in your MLOps journey, when you explore more, so you can directly implement it on yourself as well. Okay, so we have got the Docker file present, and we have created this Docker file, and we are able to run that Docker file. Perfect. Now this is looking good. Now it is working in my local system. Now the next thing that I want to do is I want to implement it on a server. So let's think about the architecture. What are we trying to do right now? So if I want to describe what we are trying to do right now is currently, okay, we have uh, we are going to host the code in the github.com. Okay, so this is where we will hosting the code. That means the code that I've got in my local system. So I'll be maintaining it as a Git repository, and I'll be pushing that code into the github.com. So I have my local repo, which is basically my folder structure, like my local folder. I'm going to host it on the github.com. Okay, now once I perform this activity of hosting my local repository to the github.com, then I will use the code which is present in my github.com. I'm going to like whatever the code that I've got. So using that code, I would go ahead and perform the build. Okay, I'll build the Docker image, and I'm going to push the Docker image. Okay, I'm going to push that Docker image to the, let's say in my example, Google artifact registry. Okay, I'm going to push that Docker image to the Google artifact registry. So the question that you might have is, what is this artifact registry, or what is the meaning of it? So think of it as a place to save the Docker image. So just like you have the GitHub to save the files, right? Your code file, think of it as artifact registry as a place where I will be saving my Docker image. Now, using the file, like using this Docker image that I have pushed, okay, what I'm going to do is I would go ahead. So I would go ahead and use this file and deploy it in Google Kubernetes engine. Now there's a reason that I've selected this Kubernetes engine. See, the reason that I've selected this Kubernetes engine, because if you look into this demo, you can replicate it on any cloud environment, because Kubernetes, the code that I'll be using, it will be the same irrespective of where or which managed Kubernetes service that you're using. You can use it on AWS, you can use it on Azure, you can use it on your custom infrastructure. So Kubernetes is a default way in which we are going to deploy our cloud applications. Okay, so as a result of this, I'll be showing you the code in the demonstration. I'll be showing you the demo on Google Kubernetes Engine, which you can easily implement it on your own environment so that you'll have a complete control of your environment and where you are deploying your machine learning application, guys. That's one of the main reason that I've chosen Kubernetes as an option of deployment. Now, apart from this Kubernetes, there are other various options as well. So like you can make use of Azure App Service if you're in Azure, or there are other application services as well in the various cloud platforms. So, but that would be specific to the vendor platform. So since the main intention is not to be specific to the vendor platform, so that's one of the major factor that I have considered while choosing this Google Kubernetes engine. Okay, now to implement this architecture, there are some system setups or the steps that we have to follow. So first and foremost, we need to have our code into our GitHub repository. So we need to have this code present in our GitHub repository. So in our case, so what I have done right now is I have hosted on my GitHub repository. So the code that I've got is Flask dev GKE. That's the repository where I have hosted the code. So what I will do right now is I would push my code to this GitHub repository. So this completes the first part, that is hosting the code on the github.com. So I have made some changes right on the code which I've got. There are some changes that I've performed. Let me commit those changes and I'll push it to the GitHub repository. So I'll say git add dot and git commit -m, and I would go ahead and like I'll just say it as updated code. Okay, that's the comment that I would mention. Now this has committed to my local repository. Now I would push these changes to my remote repository, which is hosted on github.com. So git push origin main. Okay, so this will push the changes. This would ensure that my code changes that I have got, the code that I've got in my local system is going to match the code that I have got on this uh, on the github.com. Okay, so let me refresh the page. See, there is a updated code. That's the latest commit, and the commit has been performed just now. And there's a question right here. Anurupa says that how do you come to know that the Docker file to model deployment interface? That's a good question, Anurupa. So what we have done is here in the Docker file, the command that I have used is dot and dot. So if I don't want, if I want to specifically say, or if I mention what is happening, so think of it in this way. So when I'm executing this Docker file, so what happens is in the back end, it will create a kind of an environment, virtual environment for us. And this virtual environment has Python 3.10. And this box over here, this represents my current folder. In my current folder, I have got various files like I have my app file, classification, deploy, Docker file, model file, requirements. I have all the files. So when I say copy dot dot, what it means is it will copy all the files in my current working directory to the virtual environment. So it will copy whatever the files that I've got, it will copy it over here inside this virtual environment. So this Docker file will have all the files that I have got in my current working directory so that it can execute those commands. Okay, so this has got all the file now. Now, once it has got all the file, what it has to be done over here in this environment, first thing is use the requirements.txt file. So first it was not there, but I have copied it in the previous step. So use this requirements.txt file and run this command pip install requirements.txt so that first in this new environment, it will install the same version that I have got in my local system. Okay, then I'm saying that run the same command. See, in my case, I also ran as python app.py, right? I'm just executing the same using these two commands like entry point and cmd. So that's how I'm actually integrating that's how this Docker file is ensuring that the files that I've got in my working directory is also present in this environment. Okay, so is it clear, Anurupa? Okay, thank you, Anurupa. Perfect. Okay, so what we did is currently, as of now, we had the code in a local repository, and we made use of the command of git push to push our code changes to our github.com. So I had already created the repository in my GitHub account. We have seen already in the last session how to create a GitHub repository in the last session. So I've just added the same and I've pushed the code changes. Now the expectation is I want to build the Docker image. See, to build the Docker image, I've already mentioned the code that you have to use. So the code is Docker build and you would mention it. But there's a special requirement that I have also mentioned, right? So I have to build it such a way that I should be able to push it to my Google artifact registry, which means you would require the Google Cloud account. So in my case, so I have already created, I have a Google Cloud account. So I would just go to the site console.cloud.google.com. Now, if you're someone who do not have the Google Cloud account, you can just go ahead and do a quick Google search. So if you can get the Google credits for free, like Google Cloud account, if you do a quick search, okay, so or the Google Cloud platform, so you can go ahead and perform the sign up and you'll be getting the $300 for free. Like you'll get the $300 credit for free, and you can use this to practice around and to work in this Google Cloud environment. Okay, so that's what you can do it, guys. So here in my case, so I went ahead and I have my cloud account present. So here I have to create the uh, repository for this Google Artifact Registry. So what I'll do is by logging into my Google Cloud platform, I'll search for the Artifact Registry. So there's a service that's called as Artifact Registry. And over here, I would create the Artifact Registry for me. Okay. In this case, there is a flash dev and my demo. So what I'll do is I would go since I'm going to show you the demonstration, I'll just delete the ones that I've got in my system just to avoid the confusion. Okay, so what I'll do is I will say create a repository and mention your required name. Like I'll just say Flask CI/CD. That's the name that I'm going to mention. This is a repository. The format, choose it as Docker. And region, I'll select as, let's say, US Central 1. That's the region that I'm going to select. And I would say delete artifact if I delete it, and I'll say create. So this is going to create the uh, artifact registry in my Google Cloud account. Now, in order to be able to communicate from my local system to the artifact container registry or my Google Cloud, so we need to install the Google Cloud CLI. So you can just say Google Cloud CLI. So you can search for Google Cloud CLI install. So you can quickly go ahead and install this Google Cloud command line interface. We can follow the steps here. I'll mention the uh, instruction. So this is the link that you would use it to install the CLI. And once that is done, so just follow the instruction that is present right here so that you can work with the same. Okay. Now, once you have done the installation, in my case, I have already done that. Okay. So once you have completed that installation step, so you can go ahead and validate it by running the command of gcloud hyphen hyphen version. By running the command of gcloud hyphen hyphen version. So this would go ahead and validate it whether you have the Google Cloud has been installed or not. That's an important, guys. Okay, this is one of the prerequisite step which you need to do in your system to interact from your local system to the Google Cloud server. Okay, so now once that is done, so another easiest thing that I would recommend is, okay, so another easiest thing that I would recommend is, so you can just, I think, go gcloud login. So you can simply say gcloud auth login. That's a common command that you would use it. Gcloud auth login. So just run this command. And once you run this, so you will be able to authenticate your local system CLI with the Google Cloud account. So these are the two steps that I would recommend that you do it. So once that is done, so you have your Google Cloud interface present with you and it is connected to your Google Cloud servers, then you can interact with the artifact registry that you have created. So once you create this artifact registry, if you click on this and click on the option which says setup instruction, it will show you how you need to set up. It says gcloud auth and you have to execute this command over here. So in my case, I have already done this, but I'll show you in front of you as well. So you just have to run that command and press the enter key. In my case, there's already present. So it says I don't have to worry about it. But if it's not present, it is going to ensure that you will be authenticated for the artifact registry in that region of US Central 1. Okay, this is a prerequisite, guys. Okay, now once this is done, once this is done, the next step that you need to perform is you have to push the code, whatever the code that you have got in your local system, you have to push that code to this uh, uh, like uh, to this registry that you have got. So you can actually do it right away, or what you can do is you can do it at a later point. So just to ensure that you have all the things set up, so the way in which that you would push the code is, so just take the help of the previous implementation that I have done so that I'll be able to share you the code. So you'll just say docker build and you will tag it. And when you're tagging it, you will be tagging it in a specific manner. So first is you will mention your region. Okay, I think there is already a code help. There's something that I've used already here. I'll show you this. So this is how you need to perform the tagging. So this is basically the zone in your Google account, followed by docker pkg dev, okay, followed by your project ID, followed by your repository name, followed by the image name that you want to give and the image tag. Okay, this is the format in which you have to send the commands. So I'll mention the equivalent command in my case. Okay, in my case, the equivalent command will be my zone is basically US Central hyphen US Central 1. US hyphen Central 1. You can actually get to know about its region by looking at the location US hyphen Central 1. Okay, that's how you can actually get the one, and then followed by the project ID. So you can get the project ID by clicking any resource. You can just go inside this resource and I think somewhere it will be mentioned your project ID, or you can also get it from the other pages as well. See, if you look into this, it says Civic Rhythm 404204, right? So this is basically my project ID. You can also get it by expanding your project ID that you have created. So this is my project ID. So I'll mention my project ID followed by the repository name. So repository name is basically the artifact repository that I've created, that is Flask CI/CD. Okay, I can just copy it. So I think the best part was when I copied it, it copied completely. So you can come over here in this page and click on copy. It will copy the entire structure itself. And once you mention it, okay, I'll just replace everything since it was copied. Okay, so once that is done, we can go ahead and mention the image. So for this demonstration, I'll say Flask demo. And for the image tag, I'll just mention it as latest or V1. I'll just mention it as V1. So what it means is there's no change in the code that I have done. Only the changes as how I'm naming my Docker container image. That's what this command says. Docker build -t is a command that I'm going to use it to tag my Docker image. Okay, to tag my Docker image in a specific format. So this is a requirement from the Google artifact registry. The same is true even when you're working with Azure as well. So if you're working with Azure, you will have something called as azure.acr or something. Or if you're working with GitHub container registry, so it will have something called as GCR. So this is a common activity, guys. Okay, this is not special one. I'm just mentioning it as per the requirement of this Google artifact registry. So I'll just perform the steps over here by docker build -t. This will just perform the tagging. So this will again perform the build activity with the new tag that I have just created. Okay, so once I have performed this activity of build, okay, so what I'll do is this time I'll run the command of docker push, and I would go ahead and mention this complete tag that I've mentioned earlier. US Central 1, so I'll just say docker push and mention this. So now when I press the enter key, the Docker image that I have just performed the build, it will be pushed to my artifact registry. Currently it is in the process of pushing. Let's wait. Okay, Shruti, okay, there is a Teja says about CI/CD. Can I listen to this? Okay, no worries, Shruti India. I can share some additional resources as well. Okay, let's wait, folks. Currently, it is in the process of executing. Hey guys, as I mentioned earlier, in case if you want to speak, yeah, you can join the meeting link that I have pasted in the chat, the Zoho meeting link. You can join and I can enable your mic as well. Okay, in case if you want to interact with me directly. So there are a lot of questions around I'm unable to ask the question. Yeah, you can do it in that way. Just join that meeting session and let me know in the chat window. I can unmute you in case if you have got any specific questions on the topics that we are discussing. Okay, so here we can see that the push has been completed. Now what I'll do is I'll refresh the page, which is my artifact registry that we had created. If I refresh this page, we should be able to see that there's a new Flash demo, which is a Docker container image has been pushed. And if I click on this, the tag that I have added was V1, and we should be able to see that tag. So what we have actually done is from our standpoint, so we have built the Docker image and we have pushed it to the Docker containers for this Google artifact registry. Okay, we have pushed this image to the Google artifact registry. So this completes that, okay, whatever that we have created. So it is working in line and we were able to push it. Now, what we are going to do right now is I'll make use of an automation, which we call it as GitHub action. Using the GitHub action, I would go ahead and automate everything. Like if I update my source code, I will automate such that that source code, uh, on top of that, I'll perform the build as a Docker image, and I would push that build Docker image into my Google artifact registry. So that's what I'll be implementing the automation right now. Okay, that's what we would be going ahead and implementing this automation. So let's do one thing, folks. Let's take a short break of 10 minutes. Once we are back from break, we'll implement this automation, and I'll also talk about the Kubernetes file that I've created so that we can test these in action. So let's meet after 10 minutes, guys. In the meantime, if you have got any question, let me know in the chat window. I'll try to respond it over the text, or else we'll answer it once we are back from the break. Okay, let's meet after 10 minutes. Okay, guys, I hope everyone is back. So let's continue, everyone. So before we went in for a break, so what we did was we have had written our code in a local repository. We have hosted on the github.com. We have built the Docker image and we have pushed our code to the Google Artifact registry. I mean, that's what we did in our learning journey. Now we will introduce the automation. To introduce the automation, I'll make use of GitHub Action. So this is the official documentation page of the GitHub Action. I'll tell you what exactly is this GitHub Action and we'll just show you the GitHub Action file that I have created. But before I show you the file that I have already created, so let me just to help you understand what is this GitHub Action. So this GitHub Action is a continuous integration and the continuous delivery platform. So what is continuous integration? It's a methodology where the multiple developers would go ahead and save those code changes. And continuous integration will ensure that the code changes are collated and we are able to access it without any issues at a very high level. Okay, so that's the continuous integration, and continuous delivery is nothing but it's basically once the updated code is pushed to the repository, we would go ahead and perform the deployment. Okay, so that is what the continuous integration and the continuous delivery is all about. So first, let's understand the basics as how do we write this GitHub Actions YAML file, and then I'll take you through the same. So there's a learner which says, can you show the YAML file? Definitely should. Yeah, before I do that, first let me just show you the basics. Just understand the basics. With that intuition, when you look into our implementation, it will be much clear to you. Is that okay? Okay, perfect. So let's proceed ahead, guys. So here, let's proceed ahead and let's understand. See, when you're working with the GitHub action, so GitHub Actions is basically the workflow. Okay, so like this workflow is nothing but the sequence of steps that will be triggered one after the another. So we can configure that sequence of steps that has to be performed when a certain event occurs. Like an example, when I perform the code changes to my repository, some workflow needs to be triggered. Now this workflow is defined with the help of the YAML file. Okay, the workflows are defined by the YAML file. So I'll define this workflow in the YAML file, and importantly, I'll have to place this YAML file inside a special folder that's called as .github/workflows. In my current repository, okay, I'll have to create a folder called .github, and inside that I have to create a subfolder called workflows, and there I have to define my YAML file. Okay, that's the meaning of this workflow. And each event is nothing but when I want to trigger the workflow. Let's say there is a pull request happen or there's a push request happen. So that's when I'll be defining the event. And a job will also have the job. Job is nothing but it is a set of steps that I have to execute it in a workflow. Okay, so if I want to show you with this understanding that you now had, if you look into our local repository, like the repository that I've created, there was a new folder that I had already created that is .github. Inside that, there is a folder called workflows, and inside that, there is a YAML file. Okay, that is what we have just understood as how I would place it. I'll show you over here as well. There's a .github/workflows. If I go inside that folder, there is a gke.yaml file. Okay, so that is a GitHub Actions YAML file. That's where I'll have to keep it. Next, okay, how does the YAML file would look like? The YAML file would look like something like this. First, we'll have something called as name, run, and when we have to run this, on refers to as when this GitHub action needs to be triggered, and the jobs over here describes the steps. Okay, so here it's an optional. If I just go over here, name is basically the name of the workflow. Run is basically the name of the workflow that gets generated during the run. On is nothing but the trigger when it has to be triggered, when this action needs to be triggered. And jobs over here describes the various steps. So here I can say runs on, where exactly it has to run. Here I'm saying this as it should be running those below steps on the Ubuntu run Linux runner. And then we will have to mention the individual steps. So the steps over here is nothing but what are the actions that I have to do. Okay, what are the action that I have to perform? So in our case, if I come back to our code right here, okay, so there's a name that I have mentioned that says as build and deploy to GKE. Then, okay, on under this on. So when I have to trigger this, I'm saying this as when I push it on the branch of main. Okay, when I push something to the main branch, this GitHub action should be triggered. And under the env, here I have defined some environment variables. Environment variables are nothing but the parameters that I want to use it during the runtime. So here I'm getting some project ID, my GKE cluster. This is Google Kubernetes Engine cluster. The zone in which my Google Kubernetes cluster engine is present. The image, what is the image name? In our case, the image name is, let me change it right away with the information that we have got. So the image name is Flask CI/CD, Flask hyphen CI/CD. Okay, Flask hyphen CI/CD. Okay, that's my image name. Next, image tag. So what is the tag that I want to use? I'll just say it as v1 because that was the tag that I have pushed here, right? So I'm just going to use it as v1. If I want, I can use it as latest as well. For now, to keep it simple, I'll mention it as v1 so that you can use the same settings when you're executing it. Then the zone, the artifact registry zone, it is US Central 1, and the repository name. So here, in my case, the repository is Flask CI/CD. That's the repository name. Okay. Okay. Repository name is Flask CI/CD. I think, yeah, this should be my repository. Okay. The image name here, it should be Flask demo. Okay, so these are the things that we are aware of that we have just pushed earlier and have maintained it in my environment variables. For these, we'll talk about it. Like once I create it, we'll come over here. Now let's look into the setup. Under the jobs, first thing is I want to perform the setup, build, publish, and deploy. So first, I will check out the code. So to check out the code, I have defined the step as action slash checkout v3. Then I'll have to perform the login using my Google Cloud credentials. Now, in order to perform the login from my GitHub to my Google Cloud, I need to get the login details. So in order to get the login details, so what you need to do is, so you need to create the Google Kubernetes engine. It would create a service account and you have to use that service account and configure it under the GitHub. So I'm just referring to the credentials that we are going to get from the uh, from our from that JSON file, which I'll be saving it under the GitHub action settings. Then, after that, I'm going to do the same thing. Like I would go ahead and perform the login. After I perform the login, what I'm doing is on that cluster that we have created. So I'll perform the build by using the command of docker login, docker build, and then we will push that latest uh, version of the image to my Google container registry. In my case, at least, I think that's the artifact registry. Okay, once that is done, I'm going to deploy it into my Kubernetes cluster using the command of kubectl apply -f deploy.yaml. Okay, that's what we are going to do right here. Okay, so let's go ahead and let's complete this file over here. There are some things that we need to fill in. One is the GKE project, which is nothing but my project ID, which I have to save it as a environment variables. And I also have to require the credentials file as well. So Let's first do that. First, we'll create the Google Kubernetes Engine Kubernetes cluster, and from there we would populate it. So I'm going to launch the Google GKE. I'll search for GKE. So this will help me. Okay, Kubernetes. Yeah, I'll go to the Kubernetes clusters. Okay. Now here in this page, there's already a cluster present. I can use the same cluster or I can create a new cluster. I'll show you how you can create it. I'll say create and in this page. So you can mention the details. You can simply say autopilot cluster and click on create. That's enough. That's enough for you to quickly create your Kubernetes cluster. And once your cluster has been created, okay, once your cluster has been created, you can interact with this Google Kubernetes cluster by selecting the option of actions and click on the button of connect. The reason that I'm not going to create a new one because to create a new Kubernetes cluster, we'll have to wait around 5 to 10 minutes. So instead of wasting the time, I'm going to make use of the cluster which I have created earlier. You copy this command of connect and then run it in your command line interface. So this would go ahead and fetch the cluster endpoint and it will be added to our kubeconfig file. Okay, it will be added into this Kubernetes configuration file. So once it is added to this Kubernetes configuration file, so I can interact from my local system to this Kubernetes environment. Okay, that's how I can actually do it. So I have created my Kubernetes cluster. The name is Autopilot Cluster 1. So that's what you would mention it under the GKE cluster. And for the project ID, it expects us that we create it as a secrets. So before we do that, or to get those details of the secret, I can launch the IAM, that is the Identity and Access Management Service. And here, select the service account. Once you click on the service account, select the project ID which you're working. In my case, this is a project. And here, select the option of action and click on the button which says as manage keys. And from this page, I would recommend you to create a new key. So you can click on this create new key, select the option of JSON and click on create. This will download the JSON file. Okay, this would go ahead and download this JSON file. And once you have this JSON file with you, so the next thing that comes is inside this GitHub repository settings. So you'll have to head over to your repository, which you have hosted on github.com, select the settings, and under here, there is something called as the actions, not here. Under the secrets and variable, expand the secrets and variable under the security and click on this option of actions. And from here, you will have to create a new repository secret. We'll say it as new repository secret. And you will mention the repository secret name as GKE project and mention the secret value as your project ID. In your case, so mention the project ID. In my case, it is this, my project ID. Okay, ensure that you maintain it. Now, once this is done, okay, so you have to click on this add secret. Okay, I'll show you because I have already created, it's not allowing me. So I can just mention that value and I can add that secret. Okay, now apart from that, there's also one more secret that you need to create, that is GK. The other secret is the service account key. GKE SEA underscore key. You'll have to create a new repository secret. And for the value, whatever the JSON file that will be downloaded. So in my case, if I want to show you, this is a JSON file that got downloaded, guys. Okay, this is a JSON file that got downloaded. So I can use this JSON file. I have to open it and I'll have to paste that complete JSON file over here. So since it contains the sensitive data, I cannot open it in the live session. But yeah, if you download and open that JSON file, so you can just copy all the file content and paste it here. Okay, so these are the two secrets that you have to maintain under the settings of your repository. So it will be secure. And the reason this is recommended because no one can access it except the repository owner, that is you. So it is not recommended to store such credentials in a configuration file. So create it as a secret, repository secret, and that will be referred in this GitHub pipeline file. Okay, in my case, everything is set up. So we have done all these things right here. Okay, so this will complete the file that I've got, that is gke.yaml file. Okay, now what I have to do is, as I mentioned, I'll be making use of the Kubernetes. So I'll create a deployment.yaml file, which is my Kubernetes configuration file. And there's already a deployment file created, and you just have to mention your image. Okay, you just have to mention your image. So in our case, so if I want to get the details, I can quickly come over here. Uh, yeah, I'll launch my artifact registry. This is the repository. Under this repository, uh, I would go ahead and copy this path over here. I'll just replace it. That's all. I'll just replace it. And the image name over here is Flask demo, and the version is v1. Ensure you maintain these values. Okay. So what I'm doing is I'm making use of my Kubernetes configuration file, which I'm creating it as deployment, which will use the image that we have pushed into this artifact registry. Now, once this is done, now observe the magic, guys. Okay, now observe the magic. So what I'm going to do right now is I would go ahead and update my source code. Okay, I would go ahead and update this source code to my GitHub uh, GitHub repository, and you'll be able to see that this automatic CI/CD pipeline would kick in with the help of this GitHub action, and we can validate that once the deployment is complete, we should be able to launch our application in our Google Kubernetes engine. We can actually validate it. So what I can do is I'll say git add dot git commit hyphen m. I'll say demo code. That's the command that I'm going to mention. And git push origin main. Now once I press the enter key, so this will perform the commit to my repository. Now observe something that I want to show you. If I come over here to my actions, okay, let me do one thing. Let me just come to my browser itself, this one repository itself. If you see, there is an orange dot over here. So the orange dot says that there is an action which has been already triggered. Now, if I go to my actions tab, there's an actions that has been triggered, and this action, which is my GitHub action, has been triggered just now. There were other actions. These were because of my previous testing that I was doing earlier. So automatically when I push the code into my repository, GitHub action has been triggered, and you can expand the individual steps. What is happening? First thing is it performed the authentication, and then it has performed the setup of my Docker. Then what the next step is, it is performing the build. Once the build is performed, it is performing the push to my artifact registry. Okay, once the push is performed, this would go ahead and perform the deployment as well. Okay, this would go ahead and perform the activity of deployment too. So when we say deployment, it will be deployed into my Google Kubernetes engine, that is for my Google Kubernetes cluster as a pod itself. Okay, now, okay, it looks like uh, somewhere uh, we've got an error. Let's see what is the step. Deployment flash GKE not found. Okay, let me do one thing. I think it's because there was a code over here is going to which has triggered it. So I think there was a code over here which was trying to delete the deployment, and because of that it failed. I'll just remove this code and I'll perform the retrigger, guys. I think this had to be changed. Okay, so just for the example purpose, I'll just say git add dot git commit hyphen m fix git push origin main. So let it trigger the new CI/CD action. So this will trigger a new CI/CD action. I'll come back and you can see that with the new push, a new GitHub action has been triggered. Okay, now it says kubectl, it is running the deployment file. So it has completed the deployment. Now let's go ahead and validate it. Since my local system is connected to my Google Kubernetes engine, I'll say kubectl get pods. So we can see that it is in the creation state. Let's look into the service as well. From there, I can actually get the IP address. Okay, so it is still pending. Let's wait for the pods to be created as well as the services to be up. Okay, my container is running. Let's look into the service. Okay, it is still waiting. I think this is going to create a load balancer, guys. So that's the reason it's taking a while. Okay, we can see an external IP. Now I can go to this external IP and I can go to this port of 5000. See, I'm able to access my application. Even you can try it at your end as well. I'll show you. See, until that session is timed, the session is active. You can also try accessing this URL, and you can also try working concurrently. So even if multiple users starts interacting with my application, since I've deployed on the Google Kubernetes engine, so I'll be able to like the user, every user can simply work, can interact with my servers. Okay, so that's the best part, guys. So go ahead and experiment it. So you can say 10, 20, 30 or some value, click on submit. So they should generate the prediction. Okay, that's how we can deploy our machine learning model using the Google Kubernetes engine. Now, what happens when there is any change in the machine learning model? So just to replicate this, what I'll do is I'll just come over here and I'll modify my index.html from v1 to v2, which says that there's a change that I have done on my application. Now, how do I take care of that? So there are various ways of doing it. So since I've made use of a very simple demonstration, I'll just add one more command, kubectl. Uh, I'll just add one more command right here, team. Okay. So what I'll do is I'll say kubectl delete deploy dot uh, YAML. So this is the additional command that I will do, that I will add it for this demonstration purpose. You like the best way is create it as a Kubernetes secrets and use it. So since most of you would not be aware of it, I'm just making use of a simple approach of manual deletion. In the production use case, we'll be making use of this Kubernetes secrets. Like while doing the hands-on as well, like when you're executing this pipeline file, you can remove this first line and execute it. And for the further updates, just ensure you add this file, that is kubectl delete deployment, and mention the deployment name of FlashDK. Okay, this will ensure that every time you update the code, the existing deployment will be deleted and a new deployment will be created. A very, I'll say, a raw approach for CI/CD. So obviously this is not the best one, but that's what you can think about from the beginner standpoint. Okay, as I mentioned in the production use case, we'll not use it directly in this manner. So I'll just say v2 of my code and I'll push the latest version. So I push the latest version of the code, which is my version 2, and this should automatically trigger my GitHub action. We can quickly come back and check. See, it has triggered a new GitHub action, which is going to run my complete CI/CD pipeline, which is my workflow. So once it is done, so uh, if we keep on refreshing it, so you should be able to see that new pod will be created in the backend with the latest version pointing to the version v2, which will be done automatically, guys. Okay, now let's wait for a few seconds. So I'll just say kubectl get pods just to check if it is created or not. Currently it is in container creation. Let's wait for a few seconds, guys. Okay, I can see my container is running. Now if I refresh the page, even you can try it at your end as well. So it should point to my version v2. So the code changes that I've done in my application, it has been validated and it has been pushed into my container registry, and it has been deployed on my Google Kubernetes cluster. So guys, as part of our webinar session, like this today workshop that we have got, we have seen the complete demonstration of how we can make use of Git, GitHub, and making use of the GitHub pipelines, like GitHub Actions, to implement CI/CD on the machine learning projects. Now, all these things have been implemented in an hands-on manner. Now, to get the sessions recording for your future learning purpose, so ensure that you refer to the site that I'm pinging again, bit.ly/manifoldailearning.in, where you get to uh, uh, like where you can get the sessions recording as well as the source code that I have implemented as part of a learning journey. Okay, so let me share it in the other everywhere as well. So just refer to the code, just refer to this URL. So if you go to this URL, so just click on the button access now for free. So there's already a first sessions recording is present. So I think in 24 hours, the second day session will also get updated over here. Okay, guys. So do you have any questions or any queries from the learning journey that we have got today? It's time for Q&A, so please let me know. Yeah, before that, there's one more thing that I want to let you know, guys. So to help the learners, so if you have liked the session, so I request you to share it on your professional network so that the other learners can also benefit from this session. Now, if you're someone who wants to explore more from the MLOps side and do everything just like we have done in the learning journey and implement the CI/CD as well as CD pipeline in your machine learning projects, I would recommend you to check out the course on manifoldailearning.com, which has got more than 30 hours of learning content. This course has got more than 35 hours of learning videos on implementing the MLOps, where you will be implementing an end-to-end pipeline where you will start by packaging the machine learning model, working with Git and GitHub, how you would package the machine learning model, how to work with a YAML file, working with ML flow, Docker, how to work with Docker, how we would build the machine learning application using fast API, Streamlit, Flask, Linux operating system, Jenkins, how do you monitor the production environment? How do you work with DevOps concepts like Prometheus, Grafana, Docker Compose? It is filled with a lot of advanced techniques which we will be using it in the real-time projects. And also we talk about what we would be doing once we productionalize the machine learning model. So all these things is implemented in a step-by-step hands-on manner. So this is a special price that you would see on the site, which is valid only for today. I would recommend you to check out and make the most use of the course, guys. There's one more course if you're someone who wants to implement it on AWS. There's another course which I've got an opportunity to create both of these courses with Manifold AI Learning. So do check out these courses. And I look forward to seeing you on the next webinar session, guys. And again, I want to thank each and every one of you for being so interactive in this session and asking some of the amazing questions in the session, guys. I look forward to seeing you on the next session where we'll come up with another topic. If you have got any specific topic that you want me to host, do let me know in the questions or the chat window. I can make a note of it so that the team can go ahead and like schedule it and in the upcoming sessions. So thank you again, everyone. Now, if you have got any questions, so please let me know. If you're clear and do not have any further questions, please confirm by typing as all good. And it was pleasure speaking with each and every one of you guys. Okay, I can see a lot of registrations that are coming up. Okay, Ranjita. Okay, Ranjita says, sir, I've enrolled for both. I'm looking forward. Okay, thank you, Ranjita. I can see Samiksha has enrolled, Prakash, Lakshmi, Dheeraj. Okay, thanks a lot, guys. Thank you so much, guys, for the others who have joined. But yeah, so folks, yeah, I request you to share with the other learners. They can get the most of the webinar that we have conducted. Thanks again, guys. So I'll see you next time. I'll be here for another minute for answering any other questions that you might have. And yeah, thanks, guys.
The recording has been stopped.
Okay, there's a question from Satyam. Is there any difference between MLOps and AIOps? So both are same, I would say, Satyam. So it depends on uh, how or what kind of application. where we have implemented the MLOps strategy.